Welcome back to mathsolver1117. In this video, we will explore one of the most beautiful proofs in mathematics why E square is irrational. This is a step-style challenge that combines clever logic with elegant reasoning. So, a number is irrational if it cannot be written as a ratio of two integers like p and q. Saying that E square is irrational means there are no integers p and q such that E square is equal to p by q. We will prove that this is a true contradiction. So, we will solve this as irrational means E square cannot be expressed as p over q in the ratio form of two integers p and q. So we will solve this by contradiction, that assume E square is rational. We consider that E square is rational. It means that it can be expressed as a fraction like E square is equal to p over q, where p and q are integers and q is not 0. P and q belongs to z, and the condition is that q is not equal to 0, because if q is 0, then this fraction will become undefined. Now consider the series expansion of e raised to power x such that e raised to power x we know that equal to 1 plus x square over 2 factorial plus x cube over 3 factorial plus up to so on. Now we will make it E square means substitute x is equal to 2 in this expression. You will get E square is equal to 1 plus 2 square by 2 factorial plus 2 cube by 3 factorial plus up to so on. Now we have to make E square multiply by q. So it's mean multiply by q. So this expression will become E square q is equal to the q plus 2q plus 4q by 2 factorial plus 8q over 3 factorial plus up to so on. Since E square is equal to p over q, it's mean E square multiply q is equal to p. So p will be equal to q plus 2q plus 4q over 2 factorial plus 8q over 3 factorial plus up to so on. Now we will multiply this equation by n factorial, where n is very large integer. So we will get n factorial p is equal to the q n factorial plus 2n factorial q plus 4q n factorial by 2 factorial up to so on. We solve this further. Now we will arrange this equation as pn factorial minus qn factorial minus 2q n factorial is equal to the 4q n factorial by 2 factorial plus 8q n factorial by 3 factorial. So you notice that the left hand side of the equation is an integer since p, q and n are the integers. Let's denote the integer on the left hand side as a. Now this will be a and remaining of this is 4q n factorial by 2 factorial plus 8q n factorial by 3 factorial up to so on. So now we can take common as from the right hand side 2 raised to power n plus 1 because the general term of this is goes to 2n plus 1 q raised to power q n factorial over n plus 1 factorial plus by making these substitutions 2n plus 2 and qn factorial divided by n plus 1 means n plus 2 factorial. This will continue up to so on. So we will consider these two terms large values. So then take 2n plus 1 common from these two. So you will get remaining is 1 plus and in the denominator you will take common n plus 1 and q is also. So this can be written as one plus and n factorial is also taken as common. So 1 plus 2 over n plus 2 or similarly you will get next term 2 square by n plus 2 into n plus 3 and up to so on. So you can say this as this term is again you can take common. So you will write this as 2 raised to power n can be large, so we can choose n such that 2 over n plus 2 as n is large, so 2 over n plus 2 can be taken as less than 1 over 2. So this will be equal to 1 over 4 and 2 square over n plus 2 into n plus 3 is less than 1 over 4. So we will substitute this value in this, that 1 plus 1 over 2 plus 1 over 3 1 over 4 is equal to the 2. So LCM is 2. So we will get the expression as 2 raised to power n plus 1 q by n plus 1 multiplied by 2, which is equal to the 2 raised to power n plus 2 q by n plus 1. So n is large value. So this implies that this is less than 1. So we get 2 raised to power n plus 1 divided by n plus 1 q multiplied by 2 is equal to the 2 raised to power n plus 2 q by n plus 1. Since n and the 2n plus 2 q over n plus 1 are less than 1, so the right hand side as 0 is, and we consider this as b, right hand side as b, so 0 is less than b and b is less than 1. Because the left side of the equation a is an integer, as a is integer, while b, that is the right hand side, is not integer, is a value between 0 and 1. So an integer cannot equal to the non-integer. So that's why we conclude that, so our contradiction is wrong. So E square is a irrational. So this is the proof of this question. If you found this video helpful, subscribe mathsolver1117 to get more solutions in the easy and simple way. Best of luck for your exam. Stay tuned to mathsolver1117.